In this video, we will look at the knowledge distillation versions of the early ranker. So this inherits from the baseline multitask early ranker. There's no change in the init, the forward, the train forward here. The only difference is in this auxiliary task version, we are passing labels which are not just the hard labels. This is what we used last time, but we are also passing the soft labels. These are the scores or the probabilities that you have logged from your final ranker. So you're concatenating them, hence your labels are now 2 times the number of tasks. That is why when you create this, you need to specify the input, the input of num user tasks to be 2 times the actual number of user tasks. This will help by because the task probabilities that are computed by your um, auxiliary task version of noise distillation, by this model, the task probabilities will be 2 times t, which is what you want because your labels are 2 times t. Now let's move on to the shared logits version. Let me just show you first how it's applied, and then we'll go back to see the code. Here, the number of user tasks is t. It is not 2 times t, but the number of labels is 2 times t. So we somehow we need to go from t to 2 times t before we compute the loss. There's no change in the train forward function which computes the loss. So somehow we have to change the forward function, where first it computes the baseline early anchors forward function. It gets the t logits. Then it translates them by multiplying by a weight and adding a bias, and concatenates them. This weight and bias are learned parameters that are initialized to ones and zeros, because it's natural to sort of assume that the hard labels and soft labels, since they are sort of in sync, um, they will initially be similar to each other, and then if there is a need to calibrate them, then these might deviate from ones and zeros, and that'll be learned. So the only difference, so this again inherits from the early ranker, and we initialize weights and biases. The forward function has it computes the logits, and then it translates them by multiplying by weights and biases, and then concatenates them to the original one. So now your output is 2 times t, which is what we want because the label is 2 times t.